Okay, so the goal of this lecture is to introduce you to the idea of supervised learning and of a supervised learning procedure. So the basic goal behind supervised learning is to develop methods to predict some outcome, Y, from some predictors, X. And so for now, just think of Y as a univariate outcome. It could be continuous or it could be discrete. And X is going to be a vector of things that might allow you to predict Y. So let's just look at a couple of examples. So a first example is just you might want to try and predict whether an elephant sample is from a savanna elephant or a forest elephant based on its DNA. So there, Y would be savanna or forest, and X would be the DNA data. Another example is you might want to predict whether a handwritten digit is a 0, 1, 2, up to 9 based on an image. So that's this link here. If you go to this link, you see examples here. These are handwritten digits, and you might want to be able to say, based on, learn a way of predicting for a future observed image, handwritten digit, is it a 0, 1, 2, etc. So here the Y, the outcome is the label. You want to learn the true digit 0 to 9, or you want to predict that from an X, which is an image. So the images are represented as grayscales here. Each pixel is some number between probably 0 and 255, saying how dark it is or how light it is. And so you need to, okay, that's X and Y. Okay, so you want to learn to be able to predict a Y from an X. So a supervised learning procedure, we're going to assume that to develop one of these, we have access to what's usually called training data, also known as labeled data, where you have a bunch of examples of XY pairs. So the picture I just showed you was a small training data set, or a small part of a training data set for the handwritten digit recognition problem. So it's a bunch of images and their corresponding true labels Y. So more generally, a training data set is a bunch of pairs where you get to see the predictors and you get to see the true label. And your goal is to learn a way to predict the true label, the Y, from X's where you don't know the true label, for future examples. And so hopefully from a similar population to the training data. So what I'm going to call a supervised learning procedure, you can think of it as a map from the training set to a decision rule. So here the decision rule Y hat is going to be a function of X, and for any given X, you can apply that decision rule Y hat to give you an optimal prediction for what, or hopefully, to give you a prediction anyway, for what X is. Okay, so a supervised learning procedure is a way of getting such a decision rule from a training data set. So to give you an example, in the textbook, here's figure 2.1 in the elements of statistical learning. So here the labels are the orange and blue. So the colors are the labels. And the position in two-dimensional space, that's the X's. So think of the position in this two-dimensional space as the X variables, the predictors, and the colors, orange and blue, are the Y's. And you want to learn a predictor from these training data. And so linear regression would be one way to do that. And that's actually how this particular decision rule was learned. So the black line here is actually a decision rule. So the idea is that the decision rule says, if for a future point, if it lies above the line, classify it as orange. If it's below the line, classify it as blue. So the black line is the decision rule. And it was learned in this case from linear regression. Now, of course, you could use logistic regression, and we probably would tend to prefer that because the response is binary, but they use linear regression here with blue and orange as the outcome variables and the two coordinates x and y in space as the predictor variables. Okay. So that illustrates the idea of a supervised learning procedure and a decision rule. The line is the decision rule, and a linear regression was a way of going from the training set to a decision rule, to an estimated decision rule. Okay. And generally, some procedures might provide just point estimates for y. In some cases, we might also be interested in interval estimates for y, or even a full distribution on what's the possible values of y and what their probabilities are. The simplest case is just that you have a y hat. You just want an estimate, point estimate for y. And I'm going to come back to strategies for doing that in a subsequent lecture.